Welcome back to the class. Now, the first thing we do here is to factorize, okay? All right, so this is going to give us, okay, 10 exponent x multiplying 3, okay? And then here we are going to have 5 exponent x multiplying 2. All right, so this is what we have. Now, we can reorganize this equation, or we can write it in another form. Okay, so you're going to have 10 exponent x over 5 exponent x times 3 over 2 equals 100. All right, so this is what we have now. Okay, now this 10 exponent x here can be written as 5 times 2 all in a bracket exponent x, okay? All right, so this is what we have now. Okay, now we are going to apply the product rule of indices, okay? So if you have a times b all in a bracket exponent x, this will give us a exponent x multiplying b exponent x. Now let's apply this concept here, okay? All right. So we are going to have 5 exponent x times 2 exponent x, okay? All over 5 exponent x. And then here we have 3 over 2 equals 100. All right. So this is what we have now. Now, let's reorganize our equation. Okay, so we can write this as, we can organize the left part as 5 exponent x over 5 exponent x, okay, times 2 exponent x times 3 over 2 equals 100. All right. Now, we know that anything over itself is 1, okay? So you can see 5 exponent x over 5 exponent x is 1. So here is 1. All right. Okay, now we know that anything times 1 is a thing itself. Any number times 1 is a number itself. Any variable times 1 is a variable itself. So 1 times 2x will give us 2x. All right. Now, so this is what we have now. Now, we can rewrite our equation in another form. Okay, so this can be 2 exponent x times half times 3 equals 100. All right. Okay. Now, this will give us 2 exponent x over 2 times 3 equals 100. Okay. Now, we know that any number there has a power of 1. So this can be written as 2 exponent x over 2 exponent 1. Okay, times 3 equals 100. Now here we are going to apply the quotient rule of indices. Okay, so we are going to say if you have a exponent m over a exponent c, this produces a exponent m minus c. Now, so you're going to have 2 exponent x minus 1, okay, and then times 3 equals 100. Okay, all right. Okay, now we're going to have 2 exponent x minus 1 times 3 equals, now we can write 100 as 25 times 4. Okay, so we're going to have 2 exponent x minus 1 times 3 equals, now we can write 25 as 5 exponent 2, and then write 4 as 2 exponent 2. All right. Okay. Now here we are going to introduce the product rule or the product law of logarithm. Okay, so let's introduce it. Log. Okay, so here is 2 exponent x minus 1 multiplying 3. Okay, so this is 5 exponent 2. All right, so let's quote the product rule. Now, if you have log a times b, this will give us log a plus log b. All right. Okay, so you're going to have log 2 exponent x minus 1. Okay. And then here you're going to have log 3 equals log 5 exponent 2 plus log 2 exponent 2. All right. So this is what we have. Now, we are going to apply another law of logarithm, or we are going to apply the logarithm definition. So if you have log a exponent n with a base of b, this will give us n log a base b. Okay, so you can see we have quoted the logarithm definition. Okay, all right, now let's apply this to our equation. So you're going to have x minus 1, okay, multiplying log 2 plus log 3 equals 2 log 5 plus 2 log 2. All right, so this is what we have. Okay, so we are going to have x minus 1 multiplying log 2 plus log 3. Okay, and in this part, we're going to have 2 log 5 plus 2 log 2. All right. Now here, we are going to move log 3 from the left side to the right part, or to the right side. Okay, so our equation becomes x minus 1 log 2 equals 2 log 5 plus 2 log 2. Okay, so log 3 comes here, so it becomes minus log 3. All right, so let's proceed. So you have x minus 1 log 2 equals 2 log 5 plus 2 log 2 minus log 3. Okay, so here we're going to divide here by log 2, here by log 2, here by log 2, here by log 2. Okay. All right. So now we know that anything over itself is 1. So if you're having a over a, this will give you 1. Therefore, log 2 over 2 is 1. Okay. So this is the same as x minus 1 times 1 equals 2 log 5 over log 2 plus 2 times 1. Okay. So you can see log 2 there. Okay. So you can see log 2, log 2. Okay. So that gives us log 2 over log 2. So that gives us 1. All right. So let's proceed. Okay. Minus log 3 over log 2. All right. So this is what you have. Now equation becomes x minus 1. Okay, x minus 1 times 1. Okay, x minus 1 in a bracket times 1 will give us x minus 1. All right, so our equation becomes x minus 1 equals 2 multiplying log 5 over log 2 plus 2 times 1 is 2. Okay, minus log 3 over log 2. All right. Now here we are going to introduce the change of base formula of logarithm. Okay, so if you're having log a over log b, this can be written as log a base b, or with a base of b. All right, now let's continue. So our equation is going to be x minus 1 equals 2 log 5 base 2 okay, the 5 is 2 plus 2 minus log 3 base 2. All right, so let's rearrange our equation, or let's organize our equation. So we are going to have x equals 2 log 5 base 2 log 5 base 2 plus 2, okay, plus 2 minus log 3 base 2 plus 1. All right. Now let's organize our equation. Now we're going to have x equals 2 log 5 base 2 minus, okay, log 3 base 2 plus 1 plus 2. All right. So we're going to have x equals 2 log 5 base 2 minus log 3 base 2 plus 3. Okay, this is our final answer. Kindly subscribe, share. Okay, all right.